Underneath the hood of your car, there's this secret language being spoken all the time. It's this nonstop, super fast digital conversation that lets your engine, your brakes, your dashboard, everything talk to each other. Today, we're going to decode that language and get to know the brilliant system that makes it all possible.
I mean, really think about it for a second. The moment you shift into reverse, your parking sensors just wake up, the backup camera flicks on, and maybe your side mirrors tilt down, all in perfect sync. No, it's not magic. It's a high-speed network. But to really appreciate how awesome this system is, you gotta see what it replaced. An absolute mess of wires. Okay, so check this out. On the left, that's the old way. Every single little function needed its own dedicated wire. It created this heavy, super complex, and really expensive rat's nest of copper. The solution, on the right, was a total game changer called the CanBus. It just completely replaced that entire mess with a simple, elegant two-wire system that connects everything.
So, what exactly is the CAN bus? Well, the best way to think about it, like you see here, is as the central nervous system for your car, or really for any complex machine. It's the network that carries all the vital signals, making sure the right hand knows what the left hand is doing.
Its official name is the Controller Area Network, or CAN-bus for short. Now, here's the crucial part. It lets all the different little electronic brains, or microcontrollers, in your car talk directly to each other. There's no single big boss computer telling everyone what to do. It's a decentralized system. It's a conversation, not a lecture.
And get this, this isn't some brand new tech. Development started at Bosch way back in 1983 to solve that exact wiring problem we just saw. By 1991, it was already on the road in the Mercedes-Benz S-Class. This thing is battle-tested. It's been the backbone of cars for decades.
Okay, so we know what it is and where it came from, but how does this thing actually work? How do you get dozens of devices all talking on the same two little wires without it just becoming total chaos? Well, just like a busy highway, you need some very clear rules of the road. So at its heart, it's just a simple twisted pair of wires, one called CAN high and the other CAN low. Now here's the really clever part. Instead of sending one signal, it sends two that are perfect mirror images of each other. The device on the other end only listens to the difference between them. This is a brilliant trick to cancel out all the electrical noise from the engine or other systems, making the whole thing incredibly reliable. So what happens if two things try to talk at the exact same time? This is where the real genius of CAN comes in. It's called message arbitration. Instead of messages just crashing into each other and getting corrupted, the system has this built-in way to decide which message is more important. The message with the highest priority, which, and this is a little weird, actually has the lowest ID number, always wins the right to speak. And this slide shows how that works, and it is beautifully simple. Let's say your airbag controller, super important, and your radio, not so important, try to send a message at the same time. They both start shouting their ID numbers down the wire, one bit at a time. But there's one rule. A 0 bit is dominant, and it will always overwrite a 1 bit. So the moment the radio sends a 1 but sees a 0 on the bus from the airbag controller, it knows a higher priority message is out there, and it just goes quiet. It stops talking. The airbag controller keeps going, and it never even knew there was a conflict. It's just a foolproof way to make sure the important stuff always gets through. Now you can imagine a system this robust and this efficient was never going to stay locked up in just cars. The CAN bus escaped the garage a long time ago, and now it's a hidden network that is pretty much everywhere you look. I mean, we're talking factory robots, medical equipment like MRI machines, tractors, elevators, your 3D printer at home, even satellites and massive ships. They all rely on the CAN bus for their critical communications. It's the unsung hero of modern machines, for sure. And the best part about a universal standard like this is that it's not some closed-off black box. It means that we, the hobbyists, the tinkerers, the curious minds out there, we can actually tap into this network and listen in on the conversation. And as you're about to see, getting started is way easier than you might think. All you really need to get going are these two little things: a standard Arduino board, which a lot of you probably already have lying around, and a simple, cheap CAN bus module like this MCP2515. This little board right here, that's your translator. That's your key to the network. And you just connect the module to the Arduino using these standard pins called the SPI pins. Now, I know this might look a bit intimidating with all the wires, but trust me, it's really just a matter of connecting a few pins from one board to the other. Once that's done, you're physically ready to listen in.
And the software side, it's just as approachable. This single line of code right here is literally all it takes to send your own message out onto the CanBus. You're just defining the message ID, how long it is, and the data you want to send. So why is this so cool? It means you could build your own custom digital dashboard, log performance data from your car, or even automate stuff in a project vehicle. You're no longer just a driver, you're part of the conversation.
And this all brings us to one last really crucial question. You see, the CAN protocol was designed for reliability, not for security. And we've seen this in the real world, like with that infamous Jeep-hack back in 2015. If someone can get access to this bus, they control the vehicle. So as we connect everything from our cars to our factories, we have to ask ourselves, who really holds the keys to this powerful hidden network? And what are we doing to protect it?